the channel Professor Davinci. Fundamental terminologies of a tree data structure. Tree. In a linear data structure, data is organized in a sequential order. In non-linear data structure, data is organized in a random order. A tree is a very popular non-linear data structure. So tree is a non-linear data structure, and it is organized in a random, and the elements are organized in a random order. Okay, random order. A tree is widely used in a very crucial applications or varieties of applications. Tree data structure is used. A tree data structure can be defined as a structure that is a collection of a data. We can also call as a node. We can also call as it's a collection of data. So data is called a node, which is organized in a hierarchical structure recursively. In a tree data structure, every individual element is called as a node. Node is a tree data structure, stores actual data of the particular element and the link to the next element in hierarchical structure. For example, we can say here this one. This is the tree data structure, which is organized in a hierarchical structure, and each element, this is suppose this is A, B, C, or the elements or the data. So this each element is called a node. Each element is called a node, and that has a relation between each other. Relation will be established. Okay. In a tree data structure, if n node of tree nodes, this is node. So here, how many nodes we have? In this tree, we have 11 nodes. A, B, C, D, E, F, G, H, I, J, K. So total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 11 nodes are there. There are 11 nodes. 11 nodes are there, and 10 edges. Edges. Edges means the line joining the two nodes. The relation. Let me erase this one. Edges means this one. This is the first 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 edges are there. So what is the edges? Edges is a relation or the line joining two node. Clear? So data is represented as a node in the tree data structure. So it is a random arrangement. So this tree is a perfect example for non-linear data structure. Now let us see some important terminologies. Important terminologies, right? So the first terminology is root. So what is the root? Let me erase this one. In a tree data structure, the first thing is the root. So this is the root. The first node is called the root node. Every tree must have at least one root node. We can say that root node is the origin of tree data structure. So from this root node, from this A, the other trees have grown. Clear? In any tree, there must be only one root node, and also we may have multiple root node in a tree. We may also have multiple root node. So as per our example here, the A is the root node, and the okay, A is the root node of the tree. This is the first terminology. The second terminology is a edge. Edge meaning in a tree data structure, the connecting lines between two nodes is called edge. The connecting line, already I told you the connecting line. So this is the connecting line. So the connecting line is the this connecting line is the edge. This connecting line is the this is the edges. Already I told you. And then the third terminology is parent. In a tree data structure, the node which is predecessor of any node is called a parent node. Predecessor of any node is a parent node. In simple words, the node which has a branch from it to any other node is called a parent node. Parent node can also define as a node which has a child or a children. So in this case, which are all the predecessor? So let me erase this marking. So which are the predecessor? So the predecessors are, let me draw again, the A, because the B and C, the A is the predecessor of B and C, and the B is the predecessor of D, E, F. So these are all the parent node. That means any node which has or which have child or children. So these A, B, C, E, G are the parent node. So let me better to mention here. So here root node is A is the root node, and edge, you know, the line joining the two nodes, the line joining the two nodes is called the edge. And here the parent node is A comma B comma C comma E comma G or the parent node. And then we have the fourth terminology is child. So child, again in a tree data structure, the node which is descendant of any node. Predecessor means a parent, the descendant is a child or a children of any node is called a child node. In simple words, the node which has a link from its parent is called a child node. So any link from that, this is a link from the parent. So this is a parent. So here which are the child node? With respect to A, B and C are the child node. With respect to B, D, E, F is the child node. With respect to C, G and H is the child node. Okay. So here in the tree, all the node except the root are called child. So except A, all the root node are child. So except A, all the root node are a child. B and C are the children of A, and G and H are the children of C. K is the child of G. Obviously, you know that. So descendant of any node. Descendant of any node. Sorry, why? The descendant of any node is called a child. And number 5 is sibling. Sibling, just it's understood by the simple English term. Siblings means the sisters and brothers are called siblings. In the tree data structure, the node which belongs to the same parent. So sister and brothers or belongs to the same parent, right? The same thing appears, happens here also. The siblings or the node which belongs to the same parent are called siblings. In other words, the node which is the same, have the same parent or the sibling. For example, with respect to node A, B and C are the siblings. So you can say node which has same parent are called a sibling. With respect to A, B and C are the sibling, and with respect to B, D, E, F are a sibling, and with respect to C, G and H are sibling, and with respect to E, I, J is sibling, and with respect to G, only K is that K don't have or did not have sibling. So K is a single child. Then the leaf node. The node which does not have child is called a leaf node. Very simple. The node which does not have a child is called a leaf node. A leaf node also called as a external node. External node is a node with no child. So leaf node also called external node. Leaf node also called external node, which does not have no children, no child or children. Okay, leaf node. So here, which are the leaf node? D. So the leaf nodes, or you can say this D is, remove this is not this one. So the D, I, J, F, K, H are the leaf node. So D, comma F, comma I, comma J, comma K, comma H are the leaf node. And number 7, internal node. Internal node which has at least one child is called internal node. In simple words, an internal node is a node with at least one child. Node other than the leaf node are called internal nodes. The root node is also said to be internal node if the tree has more than one node. Internal node also called as non-terminal node, also called as non-terminal node. So here, other than the leaf node are all internal nodes. For example, A is internal node other than leaf, B is internal node, E is internal node, G is internal node, and C is internal node. And then number 8, degree. The total number of children of a node is called the degree of the node. The total children of a node. The total children of a node is called degree. Here, what is the degree of B? How many children the B has? B has 3 children, so degree of B is 3. Degree of B is here this one, degree of B is 3 and degree of C is say 2. So like that. Degree of A is 2 and degree of O we have F, no child. So degree of F is 0. And the 9th terminology is level. The root node is said to be at level 0. Always the root node is said to be at level 0, and the children of the root node are at level 1, and the children of a node which are the level 1 will be at level 2, and so on. In simple words, in a tree, each step from top to bottom is called as a level, and the level counts start from 0 and incremented 1 by 1. So here, how many levels our tree has? Let me erase this one. Our tree node has 3 levels. So this is the first level, 0 level, first level, second level, third level. So this is a 0 level. Level 0, level 1, level 2, level 3. So this is the level. Okay. So we have the 3 in this one, we have 3 levels, so no need to define this one. Number 10, What is this? Number 10 is height. Height. The total number of edges from the leaf node to a particular node is the longest path, and it is also called as a height. Okay. So here, what is height? This is a little tricky to understand. Let me erase this one. I will tell you clearly what is the level. Repeating once again, total number of edge from the leaf node to a particular node in the longest path is the height of the node. Okay. For example, the height of A is 3. Okay. In short, I can say the height of B is 2. The height of just randomly. So height of this. So how the height of 3 is A is 3. Longest path. What is the longest path? Either you take K or J or I is the longest path from A. So this is 1, 2, 3, right? So the A has 3. And if you take B in a second level. If you take C also in 1, 2, C also in second level. If you take H is at the end. So it is at level 0. So this all at level 0. And D also level 0. Okay. So here 1 is okay. Don't say that B has 1 level, because sorry, 1 height. So not a level, it is a height. Okay. B has, you should not say B has 1 height. So height is calculated for the longest path from the bottom. So if we take B, what is the longest path? Is I or J is the longest path. So I or J. So if you calculate the height from the bottom, so how many height? That is 1 hop. So 1, 2. So B is the 2. Clear? So this is how we calculate the height. And then this also no need definition. Then depth. The total number of edges from root node to a particular node is called a depth. The total number of edges from the root node to a leaf node in the longest path is called as, so height is a from the from the leaf to the node, and depth from the node to the leaf. Okay, that is called a depth. Now, so just inverse of a height, it's called a depth. Let me erase this one. Let me erase this one, height. Now we are calculating the depth. From the top, A is in a 0 depth. Okay, the longest path to the C or B is, this is a 1 and 1. So the B depth is 1, B depth is 1, C depth is 1. If you take J, what is the longest path from the root? Here 1, this is 2, this is 3. So the depth of J is 3. Similarly, depth of K is 3. Depth of I is 3. What is the depth of H? 1 and 2. So depth of H is 2. Depth of H is, so I'm just bold, height. Okay. What is the depth of D? Again, this is 1, this is 2. So depth of D is 2. So depth, so height is calculated from the bottom. The depth is calculated from the top. Clear? Now very easy. Path. The sequence of nodes and edges from one node to another node is called a path. So path means what? Start from any point, travel or traverse from, take any route. It's called a path. For example, let me erase this one. I'm erasing this one. For example, I need to have a path. There are multiple paths exist. Suppose I take a path, say path 1, P1. Say path P1. Let take from any node. I start from A, I go to B, I go to E, I go to H. So the path is AEBJ. AEBJ, first path. Second path, Suppose I take the path between from C. From C, I go to G, I go to K. So second path is C, G, K. So like that. So start from any node, end at any node. It is a path. It is it's just a English language. Path means what? The sequence of node and edges from one point to another point, or one node to another node. It's called a path between the two nodes. Okay, the length of the path is the total number of node in the path. What is the length of the path? Here the length of the path is total nodes. It is of length is 4. And here what is the length of the path? Length of the path is 3. Total number of node you are visiting in the path, or total number of nodes in the path is called the length of the path. And the third thing is subtree. Subtree means a part of any tree. Already you know this, the English meaning. Subtree a part. So let me erase this one. What is the subtree? Subtree. Okay. Let me draw. Subtree means a part of the tree. So there are many parts are available. Check. For example, I can say this is one subtree, or I can say this is one subtree, or I can say this is another subtree, or I can say this is another subtree. Okay, a part of any tree is called a subtree. Understand? So this is the very basic terminologies you need to understand, you need to keep in mind. So fundamental terminologies of a tree data structure. There are total 13 fundamental terminologies or fundamental key terms we need to understand with respect to tree. There are multiple trees or there. So for coming video, I will discuss about all the trees. Clear? So root, edge, parent, child, sibling, leaf, internal node, degree, level, height, depth, path, subtree. So very easy. So this kind of suppose during the exam or in multiple choice or in a very short answer, your professor or your teacher may ask, explain the degree with a suitable example, explain the child or explain siblings with suitable example, or they may give the sample tree and they may tell find the depth of A, depth of B, like that. Okay, so understand? Clear? Have a great day. See you. Bye bye.